These notes are for AP Calculus, starting basic differentiation rules. At this point, derivatives become very easy. And I'm sorry I put you through it all, but you have to understand why a limit works the way it does and what it has to do with a limit. So that's why we had to do the whole limit process for differentiation. I still want you to understand it, and I still want you to be able to do it. But at this point, I'm going to show you how just to use basic differentiation rules. So when you want to find a derivative of something, it really truly is just the limit as a change in x becomes very, very small. But there's a pattern. But I want you to remember that a derivative is the slope of a line tangent to a function at a point. It's still the same thing. The basic differentiation, the power rule, take the derivative of a function to the nth power. You're going to bring the exponent and in front multiply it by the function, but you take the function and you subtract one exponent from it and you multiply it by the derivative of this function here. The examples will make this much more clear. So if I want to take the derivative of this function here, so this is y, I can write it as dy dx, I can write y prime. I'm going to keep going back and forth different ways so you keep getting used to them both. If I look at the function 3x squared, the derivative of 3x squared, I'm going to bring the 2 in front, multiply that by the 3, multiply by the function, but I'm going to decrease the function by one exponent. If this is an x to the 2, this is going to be an x to the first. The second one, 5x to the first. So I'm going to bring the exponent out front, multiply it by the 5, take this exponent of 1 and to subtract 1 from it, so I get x to the 0. And if I have just a 7, this is saying this is 7x to the 0 power. So I'm going to take 0, multiply by the negative 7, and then subtract 1 from the exponent, so that x to the negative first. But now I can clean it all up. So dy dx equals 6x. Anything to the 0 power is 1. So 1 times 5 times 1 is going to be plus 5. And 0 multiplied by anything is 0. So my derivative just becomes 6x plus 5. What that's saying is this function is a quadratic. If I want to find the slope of a line tangent to a point, I would plug it into this equation to give me that slope. So the slope of a parabola varies as x varies. The next example is sometimes you're going to have to just rewrite the function. So this function is the square root of x. This is the same thing as saying x to the 1/2 power. So if I want to do the derivative of that, I'm going to bring the 1/2 in front, multiply it by x, but I'm going to subtract 1 from 1/2. So 1/2 minus 1 is negative 1/2. And there's nothing wrong with this. You can leave it like this. There's very, very many forms. You could find this as 1 over 2 x to the 1/2 power, or 1 over 2 square root of x. On a multiple choice test, you'd have to recognize the different forms. But for what we're doing, most of the times, it's easier to keep it like this. The next example, g of x equals 4 over 3x to the 5th. I'm going to rewrite this one as well. So I'm going to have this as 4/3 x to the negative 5th power. Anytime the exponent's in the denominator, you can move it to the numerator and just change the power. So then the derivative, g prime of x, I'm going to bring the negative 5 out front, multiply it by the 4/3, and subtract 1 from the negative 5, so I get negative 6 power. So I would rewrite this as g prime of x equals negative 20 over 3 x to the negative 6. Once again, you can leave it like that, depending on what you're going to do with it. Or if it makes you happier, you can write this as negative 20 over 3 x to the 6th. My last example is y equals 3 over x. I'm going to rewrite this once again, 3x to the negative 1st power. So I've used dy dx, I've used f prime, I've used g prime. I can also use y prime. So I'm going to take the negative 1, multiply it by the 3, and subtract 1 from this exponent of negative 1. So negative 1 minus 1 would be negative 2. So you can leave this as negative 3 over x squared, or negative 3x and negative 2. Then there's a whole lot of rules that go with these. They're not complicated. The basic differentiation, the power rule, is most important. So if I had a constant rule, what I'm saying is anytime I take the derivative of constant, it's going to equal 0. Keeping thinking again, once again, this is slope. If I had an equation y equals 7 is a horizontal line. There's y equals 7. That's a constant. That means its slope never changes. Its slope is going to be 0. So dy dx equals 0. Another example, pi. Well, if I graph that one, pi is 3.14. There's my y equals 3.14. Slope is 0. So f prime of x is equal to 0. This trips people up. Sometimes they forget that pi is just a constant. So that's why I gave it as an example. H of t equals e. Well, e is the value 2.7 and goes on and on and on. This is also constant. Remember, it's the base of a natural logarithm. So if I were taking the derivative of this, picture it once again. E is about 2.7. It goes through there. Slope is 0. So the derivative is 0. There's also a constant multiple rule, and I've showed it to you already, just didn't think about it. It's just these problems will come up in another way later on, a little bit more abstract, so that's why I show them to you. So this is saying f of x is equal to 5 times x. My constant is x, or is 5, I'm sorry. My constant is 5. So if I want to take the derivative of that, I can say it's 5 times the derivative of x. Actually, I'll get rid of that. The derivative of x. Well, the derivative of x with respect to x is just 1. If I thought of it this another way, 5x to the first power, bring the 1 in front, 1 times 5, x to the 0 power, so this is just going to equal 5. Once again, think of slope. This is a line. Y-intercept of 0, slope of 5. No matter where you go, this slope is always 5. So the derivative of that line, 5x, is going to be 5. Trying to trick you a little bit here, but really just bringing it to your attention. Pi is a constant. I can't say it enough. So this is going to be the derivative of, it's going to be pi times the derivative of x, or derivative of y. So this is going to be pi times 0. This is just going to be 0. Another concept is sum and difference rules. You may not be given functions. Later on, you might be given just the derivatives of certain functions and asked to perform operations with them. So if I wanted the derivative with respect to x of f of x plus g of x, I want the derivative of f of x plus the derivative of g of x. So if I wanted d dx f of x plus g of x, this is going to equal f prime of x plus g prime of x. So f prime of x is going to be 3. G prime of x, 2 times 7 is 14. Subtract 1 from the x squared, I get x. I'm going to rewrite this, and I should have done that before I started. 7x squared minus 1x to the negative first power. So the derivative of this part here, negative 1x to the negative 1, I'm going to bring negative 1, multiply by this negative 1, so I get plus x to the negative 2. If I wanted to clean this up, I would just write 3 plus 14x plus x to the negative 2 power. If I wanted to subtract the two, f of x minus g of x. It's just going to be f prime of x minus g prime of x. So same values I have up here. I'm going to have 3 minus 14x plus x to the negative 2. Clean this up, I get 3 minus 14x minus x to the negative 2. Just being careful that I distribute this negative sign. And those are the basic rules of differentiation. Much better than the limit process.